In the previous video, we defined a scalar product of two vectors. Say vector A and vector B are two vectors and angle between them is theta. Then we defined a scalar product of two vectors as a vector dot b vector is equal to modulus of a vector times modulus of b vector cos theta. And by the alternative method we have discussed, and that is we have defined as if a vector has component say x1 y1 and b vector has components x2 y2, then a vector dot b vector is equal to x1 x2 plus y1 y2. In the previous classes we defined in two ways a scalar product of two vectors. Now let us look at some examples. Take one example. Example number 1. Suppose if A has coordinate 1 2 and B has coordinate 3 4. Now we have to express vector AB in the form of xi vector plus yj vector, where x is x component and y is y component of AB vector. So now let us solve it. The solution: let A is equal to 1 2 as x1 y1 and B 3 4 as x2 y2. Now here x component of vector AB is equal to x2 minus x1. x2 minus x1 means 3 minus 1 is equal to 2, and y component of AB vector is equal to y2 minus y1 is equal to 4 minus 2 is equal to 2. So we got x component as 2 and y component also as 2. So therefore AB vector is in the form of ij is xi vector plus yj vector, but x is x component, so we replace it by 2 and y by 2, so 2j vector. So vector AB we write in the form of ij. Now let us look at the another example, and the example, the question is like this: if A vector is equal to 4i vector plus j vector and B vector is equal to I vector I plus 3j vector, these are given. Then we have to find first of all a vector dot b vector, and second one a b number angle between a vector and b vector. So let us solve it. Solution: here we have a vector as 4i vector plus j vector, and b vector as I vector plus 3j vector. So first of all we have to find a vector dot b vector. So we can compare this one as x1 I vector plus y1 j vector, and this one x2 I vector plus y2 j vector. See. Now let us find a vector dot b vector. By the definition, a vector dot b vector is equal to x1 x2 plus y1 y2 is equal to, here x1 is 4 times x2 is 1 plus y1 is 1 times y2 is 3. So 4 1 the 4, 4 3 1 the 3, 4 3 7. And in b number we have to find the angle between a vector and b vector. So let theta be the angle between a vector a and vector v. Then we know cos theta is equal to a vector dot b vector by modulus of a vector times modulus of b vector. And in another form we have, in the components form, we have x1 x2 plus y1 y2 divided by root over x1 square plus y1 square times root over x2 square plus y2 square. Okay, this one we have, and here is equal to x1 x2 we have 7 by root over x1 is 4 square plus, and y1 is 1 square times root over x2 is 1 square plus y2 we have 3 square. So which implies cos theta is equal to 7 by 4 4 16 1 17 root over 17 times root over 3 3 1 1 10 is equal to 7 by root over 170, which implies theta is equal to cos inverse of 7 by 170, which approximately gives 57 degree.